Let's see the previous year questions before 2000 from the chapter gears. So here is the first question. For full depth of involute spur gear, the minimum number of teeth on pinion to avoid interference depends on dash. So minimum number of teeth to avoid interference is dependent on the pressure angle, that is Z minimum on pinion is given by 2 times of sine square phi it is. So it is dependent on the pressure angle, not on the speed ratio, circular pitch or pitch diameter. So pressure angle is the relevant parameter, that is option A is the answer. Okay, so you are finding the dependence of Z and phi. Next question, the modern gear tooth profile is given involute shape because this is very easy for curve for manufacturing. Option A says that is it very easy curve for manufacturing. Option B says that sliding does not takes place anywhere on the meshing of teeth. Option C is involute is only the profile that gives conjugate action. Option D says that change in center distance does not change the gear ratio. So here some variation will always be going to happen in the center distance. That is one of the methods to avoid interference. Okay, so that flexibility of changing the center distance has to be there. So that is the advantage the involute gear has got. So option D is the answer. Next, for pinion with 15 teeth, undercutting increases or decreases with dash increase or decrease in pressure angle. So pressure angle, if you increase, that is with the increase in pressure angle, the interference decreases. As the pressure angle increases, interference decreases. And undercutting is one of the methods to avoid interference. Undercutting means you are going to remove the non-involute portion from the root part of the teeth. Okay, when you do this process, there will be decrease in cross section. Due to the decrease in cross section, the strength of the teeth it gets compromised. So undercutting is also a method to avoid interference. Undercutting is also the result of interference. So as you increase the pressure angle, the tendency of undercutting is going to decrease. Okay, this is not a desirable thing. Okay, so with the increase in pressure angle, the undercutting decreases. Next question, interference in the pair of gear is avoided if the addendum circles of the gears intersect common tangent to the base circle with the points of tangency. So let me draw here. This will be base circle, this will be pitch circle, this will be addendum circle. Next is that for the gear, if I draw, if the addendum circle of the gear is not touching the base circle, okay, then the chance is that the addendum or the involute action, involute face of gear and involute face of pinion, both will be interacting. And if I increase the addendum radius, this is addendum, pitch circle and base circle. If I increase the addendum radius, that is if it is increased and it is touching the base circle, so it is more likely to cause interference, and that's when the non-conjugate action happens. So interference can be avoided if the addendum of both gears intersects common tangent on the base circle. That is, common tangent of both the circles, it should be intersecting. I mean to say, the common tangent of gear, that is common tangent to base circle of gear and common tangent to base circle of pinion. So addendum should be intersecting with the line of action. Okay, instead of if we increase it, then it is likely to touch the base circle. Due to that, the interference may start happening. Okay, so it is advisable that addendum should cut the line of action. Okay, so this is a true statement. Option A is the answer. Next is match the following. First one is worm gear, crossed helical gear, bevel gear, spur gear. Next is list 2, that is consisting of parallel shaft, non-parallel and intersecting, non-parallel, non-intersecting, large speed ratios. Large speed ratios is for the worm gears, that is A4. Bevel gears is having non-parallel shaft, non-parallel and intersecting it is, that is C2 it is. Crossed helical gears is for the, it is for the non-parallel and non-intersecting shaft. Helical gears is for parallel shaft, but crossed helical gears is for skew shaft, that is non-parallel and non-intersecting, that is B3. And spur gear, it is a very basic one, and that is for parallel shaft. So the code here is A4, and next is A4, next is B, that is for bevel gear, B for bevel gear, and it is for non-parallel and intersecting, that is B2, and C it is 3, and D it is 1. Okay, so this will be the code. Next question, in the spur gear, the circle on which the involute is generated is called as base circle. Base circle is the circle on which the involute is generated, and pitch circle is an important circle on which we are going to measure the most important dimensions like the circular pitch, tooth thickness. Okay, even the pitch point is marked on the pitch circle at which pure rolling action happens. Okay, so the involute generation happens from the base circle, that is option C. To make a worm gear drive reversible, it is necessary to dash. Okay, option A is center distance. It is necessary to increase center distance. Option B says that worm diameter factor, number of starts, or reduction ratio. So if you want to make the worm gear reversible, it is necessary to increase the number of starts. That is option C is the answer. Next is a 1.5 kilowatt motor is running at 1440 RPM and it is to be connected to a stirrer running at 36 revolutions per minute, and the gearing arrangement suitable for this is, so you are finding the reduction ratio, that is huge reduction is there, that is 36 by 1440. So this is equal to 36 ones and this is 36 fours and this is 40. So 1 by 40 reduction ratio. So for a large reduction ratio, we prefer for the worm gear. Option D is the answer. Next question, in order to test the efficiency of reducer gear train, 1 kilowatt input was given at input end. So input power is 1 kilowatt and the speed is 1440 RPM. That is input speed is 1440 RPM and output end measured the torque as 56.36 Newton meter. If the ratio of speed reduction in this unit is 10:1, that is N output by N input is 1 by 10. The efficiency of the drive is dash. So if that is the case, you can calculate the output speed. So N output will be equal to 10 by or 1 by 10 times of 1440 RPM it is. So this is 144 RPM. Okay, and the power given is 1 kilowatt. So efficiency will be equal to power at output divided by power at input. So the torque is given. Torque is power will be 2 pi nt by 60,000. So that is 2 pi into n. N is 1440 RPM. 144 RPM and output torque is 56.36 whole divided by this would be 60 whole divided by 1 kilowatt, or this if I make it as 60,000, then this will be expressed in kilowatts and input power will be 1 kilowatt. So this comes out to be approximately 0.849 which is 84.9, that is 85% is the efficiency. So option B is the answer.